because you know that without charts, we cannot perform algo trading, right? Now we have the data to chart the plot, but one thing is missing, and that thing is charting library, right? So for that, we can use here import matplotlib. We are only getting this 300. Similarly, like if you want to check for a whole list, let's say we have items and inside that we have a whole list. So what I'll do, I'll just copy and paste these values inside that items, and I'll write this again here, and instead of this 300, I'll just provide the whole list items, correct? And you will see that we are only getting the list which we wanted, right? So this is how we can use these functions. And welcome back to the day 22 of the 100 days of hell with Python algo trading. Today we'll be starting with one of the most important part of the algo trading, that is plotting charts, plotting graphs, because you know that without charts we cannot perform algo trading, right? So we will continue the NumPy series, and this will be the last session on the NumPy. So in this session we will learn how to plot any chart, and after that we'll learn few tricks of NumPy which will be really useful. We'll learn about some functions which might make a difference in your algo trading, definitely. So let's start with plotting a first 2D plot. So what we will do, first we'll create few points. So okay, let me first import the NumPy. Import NumPy as NP, right? Then what we can do, I'll np.linspace, and in that I will take 100 equidistance point between -10 and +10, right? So -10 to +10, and I need 100 points, right? And now we'll plot a chart for the x equals to y, and you know that what is x equals to y. So what I'll do, I'll just write y is equal to x. Now we have the data to chart the plot, but one thing is missing, and that thing is charting library, right? So for that, we can use here import matplotlib dot pyplot as plt, right? We'll also learn this completely, but for now, just you have to import this, and after that, you need to use plt dot plot, and inside that you have to pass both the points, so x and y. And when you hit shift enter, you will see that we have a graph for the straight line x equals to y. You know that, right? Now let's try to plot a chart for y is equals to x square. And if you remember, then let me know in the comments that y is equals to x square is for which kind of plots. So let's take the same 100 points. So what I'll do, I'll just copy and paste this here, and here instead of y is equals to x, I'll do y is equals to x square, correct? And now when I hit shift enter, you will see that we have a graph for parabola, because that is the equation for parabola, right? Y is equals to x square. Please let me know if you need to understand this. I'll explain in any other videos completely, right? Now let's try to plot a sine wave. So for that also, I'll take the same points, correct? And instead of y is equals to x, I'll make it sine of x. That's it. And when we hit shift enter, okay, we have to write np.sine. np, that is numpy.sine of x. And you will see that we have a sine wave, correct? It's very easy, I guess. If you have studied this in your college or your school, then it should not be difficult. Very, very basic equations, right? Now we plot a chart for x log x. So for that also, we'll keep it exactly same. So x multiplied by np dot log of x, right? And now when we hit shift enter, we'll have a logarithmic plot. And last but not the least, we can also plot a chart for sigmoid. And in fact, we can plot a chart for any mathematical operation, right? So I'll just take the same value, and here we will apply the sigmoid formula. And we have seen the sigmoid formula already, and that was 1 over 1 plus exponential of negative x, right? And now when we hit shift enter, you will see that we have a chart for sigmoid. I think we have to keep this inside a bracket. And now when we shift enter, yeah, that is the exact chart for the sigmoid function. And this is how you can plot chart for any mathematical operations. You can try yourself to apply different mathematical formulas and try to plot the chart for them. Now let's start with some important NumPy functions which will be really useful in your algo trading journey, right? So what is happening here? you will see that you have the name of function, and along with that you will be having the documentation link for that function. So if you face any issue, you can just click on the link and see the documentation and proceed, right? So let's start with the np.sort. So actually we have already seen the sort and sorted in the list, but the benefit of np.sort is that you will receive a NumPy array, right? Which can be quite useful sometimes. Okay, so let's try this. Now here we have two arrays. The first is OHLC1, which is a 1D array, and the second is OHLC2, which is a 2D array, right? So let's try to apply this np.sort on these two arrays. So I'll write np.sort, and I'll give OHLC1. So when we hit shift enter, you will see that we have received this array in sorted form, right? And so here, if you want this in a descending order, you have to use the slicing here and -1, and you will receive a descending array, correct? Similarly, let's apply this on the 2D array. So np.sort, and I'll give OHLC2. And when we hit shift enter, okay, now let's try this on the 2D array. So I'll write np.sort and OHLC2, right? So when we hit shift enter, you will receive that we have received an array, and it is sorting by default row wise. So you can see that here we had the 910, which is at the last, and 210, which is at the first, right? And if you want this column wise, what you can do, you can just write access is equals to 0, and it will be a column wise. Now you can see earlier 9875, and we have 5789. So that's how you can achieve this. And if you make it 1, it will be row wise. It is very simple actually. If you perform some practice questions, you are good to go, right? The next we have is the np.append. So here what happens? It appends values along the mentioned axis at the end of the array. So let's take the same example. So I'll copy and paste it here. Now let's apply this. So np.append and the name of the array and the value. So you can see that the 500 has been appended at the end of the array, right? Okay, now let's apply this np.append on 2D array. So how we can do that? np.append and the name of the array, that is OHLC2, right? Then we have to provide the values of the array. So here what we can do, we can create another array with the shape 4x1, right? So np.arange, and inside that we know that we need an array of 4x1, because here we have 4 rows and we just want to add another column. So 4x1, and then we can reshape. Actually here we have to give the range. So range I will give 4, and reshape I will give in the 4x1, correct? And then in the last you have to give the axis. So axis will be 1, correct, for the column. So when you hit shift enter, you will see that in this array another 0, 1, 2, 3 has been added. So it becomes now 4x5, correct? So that's how you can use the np.append. Let's move to the next function, which is np.concatenate. And with the name also, it signifies that it will be somehow adding some values to the arrays, right? Now next we have the np.concatenate, and the name also signifies that it will somehow can be used for concatenation, right? So let's create another 2 arrays. So I'll write c is equals to np.arange, and I'll give a range up to, let's say, 12, and then we'll reshape to 4x3, correct? Similarly, we'll create another array which will be d. Let's make it also 4x3, correct? And we can make the range from in here 12 to 24. Let's see the arrays. So c is this one, and this is the d, correct? So we can simply use the function np.concatenate, and here we'll provide the arrays. So the first is c and second is d. Then we have to give the axis. So axis is equals to 1, and you will see that it has been added, right? Let me show you first the arrays. So this was the print c and print d. So these were the arrays earlier, and after concatenation you can see that it has been added, you can say, horizontally, right? Similarly, if you give here the axis as 0, it will be concatenated vertically. So that's how you can use this, and it will be very useful in future because we will be always using this function, right? Next function we have is the np.unique, and with the name signifies that we can find the unique values out of any array. So let's create first an array, np.array, and inside that I'll give some values like 1 comma 1, then 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6, 7, 8. And now when we apply this function np dot unique to, let's say it is e is equals to, and here I'll give the value e. So when we hit shift enter, you will see that it will only output the unique values, right? So this is also useful sometimes. Now we have the next function, which is np dot expand dims. So means we can use this function to expand the dimensions. So you can read here that, so we can get the expanded dimensions of an array. So let's take this example OHLC1 and apply the shape. We know that it is 1D, right? So if I want to use the np dot expand dims, what I can do, I can just write np dot expand dims, and I can give the name of the array, that is OHLC1, and we have to give the axis. So let's say I provide axis is equals to 1. So when you hit shift enter, you will see that it has been expanded in the vertical direction. So now when you check the, let's say we apply f equals to this, and now when you check the shape of this f dot shape, it is 12 comma 1. Earlier it was only 12, means 1D. Now it has become 2D by expanding one dimension. Similarly, you can use axis equals to 0, and when you hit shift enter, you will see that it has been expanded horizontally, right? And even you can see the array. So let's check this, and this is the 2D array, right? So that's how you can use the expand dimension function. It's very easy. Now we have np.where, which will returns the indices of elements in an input array where the given condition is satisfied, right? So let's say we have this array, or let's take the OHLC1. So we have OHLC1, right? And we can apply here the np.where. So np.where, I can give any condition here. Let's say I want to check OHLC, all the values which are greater than 400. So when I write this, it will return the indices of those values. You can check here that this was the OHLC. Let's print these. You can see that at the index 2, 0, 1, 2, we have 499.5, which is greater than 400. And again at the index 4, 5, 6, 7, so 0, 1, 2, 3, 4, 5, 6, 7, and all these indices are greater than 400. That's why we are getting this value. Now we can also use this smartly, and we can replace any value. So let's say I use this function np.where, correct? And here the first I will give the condition. Then if that condition is true, it will replace with 0, and if false, then we will keep the OHLC1, correct? So now when you hit shift enter, you will see that all the values which were greater than 400 is replaced by 0, and remaining are all same. It will also be very useful function a lot of times when we move next further. The next function we have is the np.argmax, right? So it returns the indices of the max element of an array in a particular axis. Let's apply this argmax on the OHLC1. So np.argmax, I'll give the array name, that is OHLC1, and when you hit shift enter, it will return you the index position of the maximum element, which is 0, 1, 2, 3, 4, which is 901.3, correct? Similarly, you can use here the argmin. So let me give it argmin, and it will give us the index position of the minimum element, that is 0, 1, 2, 3, 101.0. Next function we have is the np.cumSum. CumSum stands for the cumulative sum. So let's take the array again, OHLC1. So what it will do, it will return an array by adding all these elements. So the first element will be 300, the second will be 300 plus 101, the third element will be the sum of all these elements. So it will like add cumulatively. So let's try that. np.cumSum and OHLC1, and you can see that the first we have is 300, second is 401.6, that is the sum of those these two elements. The third is the sum of all these three elements, and the last is the sum of all the elements. So that's how you can use this, and definitely we are using a lot this cumSum. Please make sure to practice this a lot, and it will help you a lot. Similarly, we have the cumulative product. So np.cum prod and the OHLC one, and you can see that it is giving us the value of the cumulative product, right? Okay, next we have is the np.percentile. So print the value of OHLC1 and apply the percentile on this. So np.percentile and OHLC1. So here we can give the value. So let's say if I give 100, because you know that in percentile, whatever the range is, the 100 will be the top and the 0 will be the lowest. It can be like if the range is from 50 to 70, then 70 is the 100 percentile and 50 is the 0 percentile, right? So give it 0, so it will give us the last value. And when we check with the 50, it will give you the middle value. And you can even check with the median also. So let's apply the np.median and you will see that these both are same. So percentile is very easy concept, and even so many exams we get the percentile values. So this might be useful, right? Okay, next function we have is histogram. So in histogram, what happens if you have seen the MACD, moving average convergence divergence, in that we have a histogram. So what happens, like we have few values and it will split those values in bins, and then it will show you the frequency of any particular value in that range. So let me show you how. And let's say we have this OHLC1, right? And I'll apply the np.histogram, then I'll give the array name, and now we have to give the bins. So bins, and we'll give a list. So I need that 0 to 500, or let's say 300, then 300 to 600, and then 600 to 999, right? So now when we hit shift enter, you will see that from 0 to 300 bin, we have 4 values. We can check there, and the first, second, and third, and fourth, correct? And then again from 300 to 600, we have 1, 2, and 3, and 4. From 300 to 600, we have 1, 2, 3, and 4, correct? And again from 600 to 999, we have 1, 2, 3, and 4. Yeah, it's true. Means we have 3 bins, and it will show you the frequency of those values inside those bins, right? Next we have is the correlation coefficient. It will tell us the relation between the arrays, right? So let's see that we have the array A. In that we have value 111, 222, 333, and we have an array B. In that we have 321 and 321. So now when we apply this one, and I'll pass the values A and B, and it will show me that it is 1, -1, -1, and 1. So it ranges from -1 to +1, and it will tell us the exact relation. So let's say if I make it here 1, here if I make it 10, it will change the value, right? You can see that it has changed the value. And if I make it, let's say 0 and some random value, let's say 20, and again -1 and 300, 0.2, and let's make it 1000. So now you can see that the value has been changed, and you can just hit and try on this. We will again cover this when we start the machine learning trading, because it's very crucial in that, right? So now the last function we have is the np.isIn, and it is same we have done already the membership function, right? So let's say we have this array OHLC1, and we want to check that whether this value 300 is in this or not. So I'll just apply np.isIn, and I'll give the array name here OHLC1 and the value, so 300.1, and it will show me that at which place it is existing, and it is existing at only the first place. And we have already seen that when we want to check the exact value, we have to use this as a mask, and I'll write OHLC1, and you will see that we are only getting this 300. Similarly, like if you want to check for a whole list, let's say we have items, and inside that we have a whole list. So what I'll do, I'll just copy and paste these values inside that items, and I'll write this again here, and instead of this 300, I'll just provide the whole list items, correct? And you will see that we are only getting the list which we wanted, right? So this is how you can use these functions, and please practice all these functions because these will help you a lot. Okay, so this is it for the NumPy library. After that, we will learn the pandas. Then we will start with the plotting libraries, and we will plot so many different charts, and we'll see that how these can be useful in the algo trading. So That's it. See you in the next video. Until then, bye bye. Take care. Have a nice day.